point Y. Okay, so this is our point Y. So the next thing we do, we have to calculate the value of point Y. Okay, so we are aware that the distance from here to here, this distance over here, right, is equal to what? This distance is 10, 20, 30, right? 30. So we know that our stress Y2 is equal to minus 100, right? Minus 30 is equal to minus 130 megapascal, right? Because this distance and this distance over here, I'm going to draw, right? This distance of 30 is exactly the same for this distance over here. So that's your stress Y2. Okay, so this is also equal to 30. So that's if you want to calculate, you can also calculate using this method. Okay, I'll show you. If this angle over here is beta, right? And then we just apply the rules of the circle, right? This angle over here will be equal to 2 beta, right? So this distance over here is also equal to what? 2 beta. Okay. So to calculate that, right, we know the diameter of the circle, right? We know the diameter of the circle or the radius of the circle. Because stress A and stress C, we know the value, right? So the tau max for XY plane is equal to minus 50, right? Plus by minus 150, and then we just need to divide by 2, right? So we know that it has to be an absolute value, right? So we know that this is equal to minus 50. Oh, sorry, it's minus. Sorry. Okay, so minus 50 minus by minus 150 divided by 2 is 50 megapascal. So we know that is the radius, right? This is all. This is another way to calculate it, okay? So now all we need to do is stress Y2 is equal to minus 100 minus by so 2 beta. So our 2 beta, right? So twice our beta, so is 50 divided by tangent 2 times by 26.565, right? So it's equal to 2 times by 26.565 tangent. Okay, so 50 divided by 1.333. Hold on, I think I might have got this wrong. Hold on. I know this is minus 100. So tangent, hold on, let me do some side work. Tangent 2 beta is equal to 40 divided by x. Oh, it's correct. How come my answer? Oh, I did 50. So it's minus 40 divided by tangent twice 2 times by 26.565. Okay. So 2 times by 26.565 tangent, okay, 40 divided by is equal to 30. So this is also equal to minus 130 megapascal. Okay. Now, how do we know that this answer is right? We have not done yet. Okay. So what we have just done is construct 2D Mohr circle for now. Okay. So we know that for now this is okay, right? So this is for our XY plane. Right? We know that point Z is over here, right? So we can construct another Mohr circle. So this belongs to our XZ plane. And finally, right, we have to meet one more criteria. The third criteria we have to meet is the maximum shear stress. If you look at the question, we have to meet that the maximum shear stress must be at what? 75. For this case, did we meet the maximum shear criteria? Not yet, until we construct the third Mohr circle. So this is the third Mohr circle. It is the third Mohr circle. Right? And if we look at this third Mohr circle, the maximum shear stress is at what? 75 megapascal. Okay, maximum shear. So this is our YZ plane. Okay, so this answer is valid. Okay, so it's so easy if you just look at the rules of the circle. If you look at the solution manual, okay, yeah, they form equations like this. Okay, good luck. Okay, I don't want to figure it out. I seriously don't want to. I just want to very easily construct the rules, knowing the rules of the circle, and just construct the circle. Okay. Now, if you were to recall, okay, let me see on the chat. Anyone have any question? No. Okay. If you were to recall, I joined point X into stress A. Yes or no? Now, there is another way of doing this, right? And the other way of doing this, is it possible now to do point Z to this point over here? Right? If I can go one way, I can go the other way. But is the answer correct at the end of the day? So I'm going to, like, it's normal, right? We will say, Eugene, you know the solution is like a cooking show, right? You've seen the solution before. That's why you lure us to do from point A or stress A to X. What if we join the line from X to Z, right? Point X to Z, and then we construct 3D Mohr circle. Is the answer valid? Okay, here we go. Okay, so we're going to do that now. Okay, so again, that's why I like to show you why the answer is correct and why this answer is wrong. Okay, so there you go. So again, I'm just going to do the negative side. Minus 160, 140, 20, 80, 60, 40, 20, 0, 20, and 40, 2, 4, 6, 8, 10, 2, 4, 6. Okay, so this is as usual our normal stress. Then we look into our shear. So 20, 40, 60, 80 shear clockwise, minus 20, minus 40, minus 60, minus 80 shear anti-clockwise. So again, sketch our operating limits. So we cannot be more than 75, 150, okay. So again, we're going to have our minus 70 line. Our minus 40 line, 40, our shear line, sorry. Shear, there's no minus or positive, it's entirely dependent on the rotation of the element. Okay, so we know that this is our point X. We know that this is our point Z. Now we're still going to apply the rules of the circle. Okay, so I'm now going to construct point X and Z, draw a straight line. Still applying the rules of the circle. Okay, then I'm going to copy, paste, and then rotate by 90 degrees. Right. Okay. So now over here, this is my stress A. I'm going to call this one stress A. Right. Okay. So to calculate stress A, we know that this is beta. We are going to determine beta over here. Okay. So we know that tangent beta is equal to 40 divided by 70. Right. So beta is equal to 40 divided by 70 inverse tangent is equal to 29.745 degrees. Now we want to calculate stress A. So stress at point A is equal to minus 70 minus by tangent of 40 tangent by 29.745. So this will be equal. So again, we're going to calculate where the stress average is, because only from the stress average we can draw X across the center of the circle to find point Y. Okay, so 70 or tangent 29.745 times by 40 plus by 70, so it's minus 92. Okay, so minus 92.857 megapascal. So the stress average. Okay, now we are looking for stress average. Okay, so it's equal to 0 plus by minus 92.857. And then you divide by 2. So this is equal to 92.857 divided by 2 is equal to 46.429 minus 46.429 megapascal. Okay. So we're going to sketch the position of the stress average. Okay, it's going to be somewhere around here. This is our point O. And then I'm going to draw a line from X past point O to the shear line of 40. Why the shear line of 40? Because at point Y, if you look at the question, at point Y, right, you have a shear stress of 40 megapascal. That's the only reason. So this is your point Y. Okay. So now we can again construct or sketch out our Mohr circle. Okay. So this is our, so I'm just going to 1 2, so 46.